What I'm asking you to do is actually just integrate x squared plus 4x minus 2 with respect to x. I'm doing it with respect to x because I'm doing it between the x-axis, between 3 and 1. So if I put 3 and 1 there, what's my next step when I get that? I'm trying to integrate that.
Substitute both 3 and 1 x equation.
Before I do the substitution part, I've got to integrate it first, yeah. So I integrate that. That now becomes x to the power of 3 over 3 plus 2x squared minus 2x. And now I put in square brackets. I put in square brackets to let me know I have to substitute in 3 and 1 later on. Now what I do? That substitution that I was just talking about. So 3 to the power of 3 over 3 minus 2 lots of 3 squared minus 2 lots of 3. That gives me a number minus that from 1 cubed minus 3 plus 2 lots of 1 squared minus 2 lots of 1. Is that right? Okay, what do I get there?
15 minus a third.
15 minus a third.
21. Yeah.
3 to the power of 3 is 27 divided by 3 is 9, isn't it?
Yeah, 21 minus the third.
That should be it. Sorry, that should be a plus, shouldn't it? Sorry. So 21 minus a third. Is that what you're saying? So therefore, my answer should be 20 and 2/3. Does that make sense? Does that seem like a lot of work? Is it exactly the same as the question we were just doing before? But now it's in the context, eh? So you remember when you're finding a definite integral, what you are finding is the area between the curve and the x-axis. So far, that's what you've been doing. And the reason why you've been doing it between the x-axis is because you've been differentiating it with regards to x, with regards to that x-axis. So if I ask you later on to find one between the curve and the y-axis, what might you have to do?
Integrate with respect to y.
Yeah, integrate with respect to y. Okay, which again is another little challenge, but we'll get there eventually. So this one here, determine the shaded area. Give you a little bit of time to have a crack at that. Don't think I am playing a trick, but so that we're talking about the shaded area. We're trying to find the area. What we're going to do is integrate x squared plus 4x with respect to x. That's what we're trying to do, eh? Is that right?
-8.
Between where?
-8 over 3.
0 and -4. Right, so do that. That's going to become x cubed over 3 plus 2x squared.
Thank you, Sam.
For those that weren't here the other day, where does the plus c disappear to? Michael, did you hear that? Michael, did you hear that? The plus c disappears here because what we end up doing is going plus c minus another plus c, and those will cancel. Okay. This will turn into 0 cubed over 3 plus 2 lots of 0 squared minus -4 cubed. No, I'll put the -4 in brackets plus 2 lots of -4 squared. What does that give us? Well, that first part's 0, isn't it? -53 and 1/3.
Sam, you would have done 4, not -2.
It's negative though.
Did you do -4 or +4?
-4 cubed should be what is that? 64 divided by 3 is 21 and a third. We add
8 over 3.
32 to that.
Yes, we got it right. We can't count.
You didn't put it in brackets. So was it 10 and 2/3? 10 and 2/3.
So 3 and a third.
So therefore I got an answer of negative 10 and 2/3. Is that right?
That was up to you guys. Solely up to you guys.
You said 12.
Oh, no.
Gentlemen, thank you. Did we get an answer of negative 2 and 2/3?
Yeah. Was that 8? Right, you know, 12.
Why did you get positive 10 and 2/3?
Wow. Okay.
What's the answer?
Oh,
Positive 10 and 2/3 is the answer because we're asked to find the shaded area. Now, can area be a negative answer? No. So it's positive 10 and 2/3. What does the negative indicate with regards to that area? Its position. So it identifies that it's below the x-axis. Okay. So my answer is 10 and 2/3. That's my area. So in other words, the area is the absolute value of your definite integral. Okay? Any questions with that? Okay.